Okay, so now we're going to talk a little about power. Power is work divided by time. And the units for power is joules, which is the units for work or energy, divided by time, which is units per second. And so that's a watt. And technically, I should have it the other way around. A watt is defined as a joule per second. And so we're just going to illustrate this by working out a problem. We're going to say, what is the power output for a 60-kilogram woman who starts from rest, runs up the stairs 3 meters high, and is going 2 meters per second at the top of the stairs 3.5 seconds later. So she starts at the bottom, right, where at the bottom, V naught is equal to 0, and then V at the top is 2 meters per second, right? And so again, we have the power is equal to the work divided by the time. Well, the work comes from the work equation, right, which is the work is equal to the change in kinetic energy. And since we have potential energy here, we can skip all the theatrics and just say work is change in kinetic energy plus change in potential energy. We've done this enough time that we can just write this down. Normally, I would have work and divide it up into conservative and non-conservative, but now this is just the non-conservative part. We have kinetic plus potential. This is the way I would just write it normally. So this person's kinetic energy changes and her potential energy changes. So if I want to figure out what the work is, I have to say it's KE final minus KE initial plus PE final minus PE initial. Right. And so I can say, look, my initial potential energy is 0 because I picked the height at the bottom to be 0 like I've been doing. And I can say, so that's really all I have here because, I also have my initial kinetic energy is 0, right? Because she starts from rest. She started from rest. And so that means that the work done is just 1/2 mv squared, where v is my final velocity, plus mg times the final height. And that's 1/2 times 60 kilograms times 2 meters per second squared plus 60 kilograms times 10 meters per second squared times 3 meters. And so this is 120 joules plus 1800 joules, which is 1920 joules, right? That's the work done. And so if I want to calculate what that is, I can say, well, the power is the work divided by the time. That's what the work is. And so it's 1920 joules divided by 3.5 seconds, which is equal to 640 watts. So that's the rate she was using that much energy. That was the rate she was using energy to do that activity in the time allowed. If it took half as much time, this number would be twice as big, right? If she could have done that in 1.75 seconds, this would be 1,280 watts, and so on. So normally we're paying for energy, right? And so let's just talk about energy costs for a minute. For electricity, if you look at your electric bill, you're generally charged per kilowatt hour. It's like 12 cents per kilowatt hour, or $0.12 per kilowatt hour. Kilowatt hour is a unit of energy, right? Because if you remember, we said in the last section, we said power is equal to work over time. Well, work is an amount of energy, and so we can say, look, energy is power times time. So it's watts times seconds or something like that. But we can do it in joules if we wanted to. But this is just another unit of energy. So we can say, 1 kilowatt hour is equal to 1 kilowatt hour. And we're just going to convert this into joules and see how many joules it is, right? A kilowatt is 1,000 watts per kilowatt. And so if I multiply, this is equal to 1, right? Because 1,000 watts is the same thing as a kilowatt. And so that'll cancel a kilowatt and give me watts. And now I have the hour. I want to change that into seconds, so I can multiply it by 60 minutes per hour times 60 seconds per minute. Again, and the things in parentheses are equal to 1, and so I'm not changing the value of that. And so I have a kilowatt hour is equal to 1,000 watts times 1,000 watts times 60 minutes times 60 seconds. The minutes cancel, the hours cancel, right? And and I'm left with seconds. The seconds don't cancel, right? And so this becomes 1,000 times 60 times 60. 60 times 60 is 3,600. So this is 3,600 times 1,000, which is 3.6 million watts times seconds, because that's what I'm left with. But a watt times a second is just a joule, because a watt is a joule per second. We already saw that. And so this is 3.6 times 10 to the 6th joules, right? That's what a kilowatt hour is. Let me write it the way I was writing it before. And so a kilowatt hour, right, is a much more reasonable number to use to measure human energy consumption than a joule. If you're paying 12 cents per kilowatt hour, a typical electric bill might be $120. So you might use 1,000 kilowatt hours a month, or on that order. So you wouldn't want to be charged for 3.6 billion joules. And so a kilowatt hour is like talking about a mile or even a astronomical unit or a light year or something, when you're talking about a large amount of energy. It's a large amount of energy in human terms, but not in astronomical terms or something like that. And so that's how much you're getting charged. It's 12 cents for every one of these, or one of those, or one of those, right? And so let me just do an example. So what's the cost of operating a 200-watt computer 6 hours per day for 30 days, right? And so so the power is equal to 200 watts. If I want to multiply that by 1 kilowatt to get it in kilowatts over 1,000 watts, then that's 0.2 kilowatts, right? And then energy is equal to the power times the time, right? And so the time is 6 hours. So in this problem, we're going to ask, what's the price of operating a 200-watt computer 6 hours per day for 30 days if the rate or the cost is 12 cents per kilowatt hour, right? And so what you're paying for is the energy, right? It's the dollars per energy, and so we want to multiply this number by the energy to get the dollars, right? The energy we get is just the power times the time. This comes from the work equation, right? Power is work over time, but work is just a type of energy, and so you can just write that as power is energy over time, or energy is power times time, right? In this problem, the time is 6 hours per day times 30 days, right? And so that's 180 hours, right? Something like that. And so the power in this problem, the power is 200 watts, but we want it in kilowatts, so we're going to multiply that by 1 kilowatt over 1,000 watts, right? And that gives us 0.2 kilowatts, right? And now we've got to multiply it by the time, and so the energy is the power times the time, which is 0.2 kilowatts for 200 watts times 180 hours, because it's 6 hours a day times 30 days, right? And so this gives us 36 kilowatt hours, right? And then I can say that the price is 36 kilowatt hours times the rate, which is $0.12 per kilowatt hour. Oops. Right. Kilowatt hours cancel, and I get $4.32.